Today I'm going to teach you about geometric probabilities. So let's start. If AD is 20, AB is equal to 8, and CD is 7, what is the probability that a point chosen at random on segment AD will be located at segment BC? So what we're going to calculate is the probability of a point will be chosen over that region. So the probability of a point will be chosen in segment BC is equals to the length divided by its total length. So the length from B to C divided by the total length of the segment. So this is pretty straightforward because the numbers are already have given to us. So in order for us to calculate the length on segment BC, let's call it x. So the sum of it will just become equals to 20. So 8 plus 7 is going to be 15 plus x equals to 20. We can just transpose 15 to the right side, it will become negative, and subtracting it, we got 5. So this line segment BC is equals to 5. And the total length of the segment is 20. So this is going to be 1/4 and then 0.25. So the probability of the point that is going to be chosen at line segment BC is equals to 25%. So now let's move here. Point J is randomly chosen on segment AC. What is the probability that it is chosen within 6 units of point B? So what we're going to look here first is the point B. And then in the problem it says within 6 units of point B. So we're going to move from here to here. 6 units from point B. So the probability that the point will be chosen on point B is going to be the length divided by the total length. So how would we calculate the length of B? So in order to do that, we're just going to add 7 and negative 3. So we're going to make negatively positive because length is a scalar quantity. And the total length, we're just going to include the line segment A to C, and we're not going to include the number that is greater than 7. Because on the problem, it states that randomly chosen on segment AC. And that 9 is outside of the domain of C. So we're just going to add these things and we got the answer. So the total length of this segment is 12. So this can be reduced 5 times 2 and 6 times 2. 2's will cancel. And we got this 5/6. And 5/6 is 0.83 refitting or approximately 84%. So the probability is going to be 84%. Why do I keep eating my words? That was funny. So this is the probability of the segment. Point X is randomly chosen in the rectangle shown below. What is the probability that point X will be located within the triangle? So what we're going to calculate is the probability of point X that will be located inside of the rectangle, which means the triangle. So in order for us to calculate that, we're just going to divide the area of triangle divided by the area of square. So the area of triangle is just 1/2 base times height. So the numbers are already given. So the base is equals to 6 and height is equals to 5. So we can just divide 6 by 2 and we got 3, and then we get this 15. So the area of the triangle is equals to 15 square units. Now let's calculate the area of this rectangle. So the area of the rectangle is just length times width. Our length is already have given, it is 10, and our width is 6. So 10 times 6 is 60. So the area of this rectangle is 60 square units. So we're just going to divide these things and we are going to calculate. We can have the probability. So this will become 5 over 3, and this will become 20 times 3. So we can just cancel the 3, and this will become 1/4, which is approximately 84%. So this is the probability that point X will be located within the triangle. That was a high chance, right? Calculate the probability that point X will be randomly chosen in the sphere shown below. So we have cube here, we have a cube and a sphere, and the sphere is inside the cube. So for us to calculate the probability of the sphere that point X will be randomly chosen in the sphere, we're going to do is not the area but the volume of the sphere and divided by the volume of the square. So the volume of the sphere is just 4/3 pi r cube. Why did I say square? It's cube. Okay, here, cube. So the radius is 5 inches. So we're just going to raise it by the third power. So using our calculator, what we will have here is just 523.5987756 cubic inches. Now let's calculate the area of, oh no, not the area, but I did choose area A symbol instead of volume. So going to calculate the volume of the cube, which is 5 raised to the third power. So we got 1728 cubic inch. So the area of I keep misinterpreting. So we're just going to plug it in this button, in this ratio. So we got that. So using our calculator, what we will get is 0.303, which is 30.3%. So the probability of point X that will be randomly chosen in this sphere is 30.3%. So that's it for this video.